function notation refers to inputting values for x and solving for values of y as your output. So y and f of x are the same thing. We know that from before. F of x means the function evaluated at x. So when we want to plug something in for x into our function and come out with a y value, we're going to plug in the value of x and then just solve. The x is called our independent variable, which is the input, and the y, or the f of x, is the dependent variable, which is our output. So in this example, we want to evaluate f of x when x equals 2. So the way we would write that, it's denoted by f of 2. So when you plug the 2 in for where the x was, it's called f of 2. So if I have a function that's 7x squared plus 9x minus 5, and I want to find f of 2, I would say f of 2 equals 7 times 2 squared plus 9 times 2 minus 5. And then I just evaluate this, and then I end up with 41. Okay, so the f of 2 on the left-hand side of the equal sign, you're not doing anything with that. You're not actually dividing out the 2. You're not solving anything on the left-hand side. That's just stating that the function is going to be evaluated at 2. 2 is what you plug in for x. The answer that we get is our output value, or our y, so 41. So using the f of x from above, find f of negative 1. So if we want to find f of negative 1, negative 1 is going in for x. So we're going to have 7 times negative 1 squared plus 9 times negative 1 minus 5. And we're just going to evaluate that. And when we do, we end up with negative 7. And so it's as simple as that. You're just plugging in, and whatever's in the parentheses goes in for x, and then you're just solving. Now in these examples, the main thing you want to do is you want to make sure that you match up the right function with the correct letter. So in number 1, f of 2. So you're going to find the f function and plug 2 in for x. So our f function is the first one, and we're going to plug 2 in for x. So 2 here, 2 here, and 2 here. Okay, and then we're just using PEMDAS to simplify this as much as possible. So when we go to solve this, we'll end up with 4. Okay, now h of 3, we're going to take the h function, and we're going to plug 3 in for x. So we're going to use 12 times 3 to the 4th minus 3 plus 3 times 3 to the 7th minus 1. And again, just simplify this according to the order of operations. We'll end up with 7,529. Okay, k of negative 2, we're going to use our k function. So our k function is 6, and instead of x, we're going to put in negative 2, plus 25, plus 4 times negative 2 to the 4th, minus negative 2 squared. And again, evaluate this. So we get 73. Now for number 4, it says g of a. Now, we're going to use the g function because we're going to match that up. But instead of x, we're going to plug in a. So in this case, we're going to get an expression. We're not going to get an actual number answer. So I'm going to plug this in to the g function. So 50 minus 3. And instead of x, I'm putting in a cubed plus 5a squared. Okay, and that would be our answer. So we're not going to have an actual number, we're going to have an expression. Okay, so that can happen. And a lot of times on the SATs and the PSATs, you see questions with function notation like this, where they give you variables that you have to plug in for other variables. Okay, you're literally just plugging it in and evaluating it. Now if we look at some of these, so g of a is 4a. We want to find g of 2a. So we're just replacing what was in parentheses with the new thing in parentheses. So we're replacing a with 2a. So here, where we have an a, we're going to plug in a 2a instead of the a. So this gives us 8a. P of t equals 4t minus 5. We want to find p of t minus 2. So we're going to take, instead of t, we're going to take this whole t minus 2, and we're going to plug it in for t. So it's going to be 4 times t minus 2 minus 5. And then we can distribute the 4, and we end up with 4t minus 8 minus 5. And then we just combine like terms together. So we get 4t minus 13. Okay, so f of n equals n squared minus 2n. So we want to find f of n squared. So we're going to take n squared, and that's going to go in to this n, but it's also going to go into this n. So instead of n, we're going to have n squared, and then we're squaring it, minus 2, and then instead of n, we're going to put in n squared. If it makes more sense for you to leave wherever the variables are, leave it as like a space with parentheses. So like for example, anytime you see like an n in that example, you know you're going to put something else in there. So you can leave it blank, squared minus 2 blank. So in the blank is what you're going to put in the thing that's in the parentheses. So the n squared is going to go into those blank spaces. And then we evaluate this, and we get n to the 4th minus 2n squared. Okay, and then this last one says find f of a plus 1. So we're going to use the same function that we just used, the f function. So instead of n, we're going to put in a plus 1. So let's write it with the blanks. So it's blank squared minus 2 times blank. And in the blank, we're going to put a plus 1. So we're going to put a plus 1 here, and we're going to put a plus 1 here. So now we're actually going to just evaluate this a little bit more. So a plus 1 squared, you would have to write that twice and FOIL it. So a plus 1 and a plus 1. Minus, and then we're going to distribute that negative 2. So minus 2a minus 2. So if we FOIL this out, we're going to end up with a squared plus 2a plus 1. And then we have that minus 2a minus 2. So we're just going to combine all of our like terms together. We have a squared. 2a and negative 2a cancel out. So then we have 1 minus 2, which is negative 1. So if we try some more of these, we want to find w of 3n. So we're going to leave the n as a space, and we're going to plug in the 3n. So then we evaluate this, and we get 12n plus 2. And the next one, we're going to plug in negative 4n in for our n. So we're going to leave that cubed minus 5 blank squared. And we're plugging in negative 4n, negative 4n. So we're going to cube negative 4n. So that's going to give us negative 64n cubed. And then we have to square, and I'll leave this negative 5 for now. We're going to square negative 4n, so that gives us 16n squared. And then we're just going to distribute. So negative 64n cubed minus 80n squared. Okay, so now we want to find h of x plus 2. So we're going to leave x as a blank, and we're going to plug in x plus 2. So we're going to distribute, and we end up with 4x plus 8 minus 2, which equals 4x plus 6. And then the last one, leave a blank for the a, cubed minus 5. Instead of a, we're plugging in x minus 4. So here we have to write x minus 4 3 times, and we have to FOIL it out. So we would FOIL it in groups of 2 first. So we would have something like x minus 4, x minus 4, x minus 4. I'll put minus 5 at the end. So if you FOIL out 2 at a time, that's going to give us x squared minus 8x plus 16. And then you want to FOIL that with the x minus 4. And then once you FOIL that, you're going to subtract 5 from it. So we end up with x cubed minus 12x squared plus 48x minus 69.